Imagine a massive global tech company where 75% of the new software code isn't actually written by humans.
Right. It's written by an AI.
Exactly, written by an AI. And the human engineers are basically just, hitting approve. And that doesn't sound like a pitch for a sci-fi movie anymore. As of April 2026, that is the literal reality at Google.
It's just a staggering statistic. I
Yeah.
mean, it completely reframes how we need to look at what just happened in the enterprise tech space this week.
It really does. So welcome to a very special deep dive. Usually when we talk about a software update, there's this expectation of incremental change.
Yeah, like a new button here or maybe a slightly faster loading screen.
Exactly. But if you look at the news cycle surrounding Google Cloud Next 26 in Las Vegas, and we're specifically looking at the announcements published between April 19th and the 25th, that incremental model is completely shattered.
Oh, totally. We are looking at an enterprise technology landscape that has just been, well, entirely rewritten.
Yeah. And the big overarching theme here is the decisive end of the chatbot phase of AI.
Right, because what Google formally announced is the arrival of the agentic era.
The agentic era.
Yeah. I mean, we are moving past AI that just answers a question when you prompt it.
Hmm.
We're talking about autonomous systems that actually execute complex multi-day work on your behalf.
Like they operate with the independence of a digital employee.
Exactly.
Okay, let's unpack this because our mission today is really decoding how Google literally just rebuilt its entire AI stack, right? From custom silicon chips humming in data centers all the way up to the enterprise software you use every day.
Yeah, and specifically to run these autonomous agents.
But, you can't just deploy millions of digital workers overnight. You need a massive breakthrough in the underlying science first.
Precisely. You need a paradigm shift in how these models actually learn.
Right.
Historically, training a massive frontier-level AI model required all the silicon chips to be in one physical location, perfectly synchronized, which is, incredibly fragile.
Because if one server rack out of thousands happens to fail,
The entire training run can stall or crash.
yes, it's like having a string of vintage Christmas lights. Like if
Yeah.
one bulb burns out, the entire string just goes completely dark.
That is a perfect analogy. The entire system is basically held hostage by its weakest link. But this week, so on April 23rd globally, DeepMind published a new asynchronous training architecture.
Okay, what's the headline on that?
So on the DeepMind blog, the headline is Decoupled DiLoCo.
DiLoCo.
Yeah, it stands for Distributed Low Communication. And they combine this with their pathways system to create what they call fault-isolated islands of compute.
Okay, wait, I want to make sure I understand this. Fault-isolated islands means that if one data center in, say, Ohio goes down, a data center in London just keeps humming along.
Exactly. It's like transitioning from those fragile Christmas lights to a modern independent power grid. If one city's grid goes down, the rest of the country stays online. The training just routes right around the damage. And the metrics on this are incredible. I mean, under high hardware failure rates, this new architecture achieved 88% good put.
Wait, good put.
Yeah, it's a networking term for useful processing time.
Oh, okay.
It means 80% of the time, the system was actively doing useful work. It wasn't just waiting around to synchronize or recover from crashes.
That's huge.
It is. And perhaps more importantly, it reduced the required inter-data center bandwidth massively.
Yeah.
Like to link 8 data centers together, they used to need 198 gigabits per second of bandwidth.
Right.
With Decoupled DiLoCo, they need a mere 0.84 gigabits per second.
Wait, really? Less than 1 gigabit? That's basically the speed of a standard high-end residential internet connection.
Exactly.
You don't need specialized, ultra-expensive fiber optics anymore.
No, you really don't. You can stitch together different generations of hardware across the globe using standard internet cables. It completely changes the economics of AI development.
So you don't need to build a single multi-billion-dollar flawless supercomputer in one building anymore.
Precisely.
And once you have that resilient foundation, you can start building agents that actually do the heavy lifting. Which brings us to the Google DeepMind and Gemini API releases from April 21st.
Right, the new agents.
Yeah, specifically Deep Research and Deep Research Max.
Announced globally on the Google blog and the Gemini API changelog.
Right, and these are autonomous research agents built on Gemini 3.1 Pro. But let me push back on this a little bit because we've had AI search tools for years, right?
Sure.
I can go to an AI, ask it a question, and it summarizes a few web pages.
Sorry.
So are these new agents just glorified search engines that format the output to look like a professional report?
It's a completely fair question, but the underlying architecture is fundamentally different. It really comes down to a concept called test time compute.
Okay, let's break that down. What is test time compute in this context?
Well, traditional AI search models use all their compute power during their initial training. When you prompt them, which is the test time, they just predict the next most likely word almost instantly.
Right, they retrieve documents and summarize them in seconds.
Exactly. But test time compute means giving the AI permission to actually think and use massive computational resources after you ask the question.
So instead of just spitting out the first thing that comes to its digital mind, it like pauses to strategize.
Yes, exactly. It enables long-horizon iterative planning. These deep research agents are designed to synthesize data autonomously over hours or even days.
Wow, days.
Yeah, so if you ask it to analyze a competitor's supply chain, it formulates a hypothesis. It queries the public web. Then, using something called the Model Context Protocol, or MCP, it securely queries your private enterprise databases.
So it's looking at the public internet and your company's private internal data simultaneously.
Yes, and here's the really crucial part. If it realizes it hit a dead end, it pivots its strategy.
It just figures it out.
Yeah, it reasons its way out of the roadblock. It will natively generate data visualizations, map out trends, and ultimately hand you a fully cited 30-page professional-grade report.
That's wild.
I know, it's not searching, it's executing a prolonged cognitive workflow.
That is a massive leap. But if these agents are now capable of doing multi-day research tasks, it begs the question, where do they actually live inside a company software?
Right.
Because you can't just have an autonomous agent running wild on a single employee's laptop. It needs a secure, manageable home.
And that leads directly to the enterprise platform overhauls.
Okay.
On April 22nd, Google Cloud launched the Gemini Enterprise Agent Platform. This is a unified environment that effectively absorbs all of their previous AI tools.
This was on the Google Cloud blog, right?
Yeah, globally. And they rolled out things like Agent Studio, an upgraded agent development kit, and a critical feature called Memory Bank.
Okay, wait. What happens to all the legacy Vertex AI tools that thousands of developers already use? Are they just obsolete now? Like, do companies have to rip out everything they've built over the last 2 years?
No, not obsolete, but completely subsumed.
Subsumed.
Yeah. All future development will ship exclusively through this new platform. Google is signaling a major philosophical shift here. For the past couple of years, the goal for a developer was managing a large language model. We called it MLOps, machine learning operations.
Right.
But managing a single model is no longer the end goal. The goal is managing the agent that uses the model.
And that's where that memory bank feature comes in, right?
Exactly. If you have a digital employee doing work for you over a week, it needs to remember what it did on Monday. Memory Bank gives these agents persistent long-term memory.
That makes sense.
It allows them to recall past interactions, learn from their mistakes, and even collaborate with other agents on the platform. It's the end of standalone MLOps and the beginning of persistent digital workforces.
And it's not just for specialized developers building custom tools either. This agentic behavior is being baked into the software you and I use every day.
Oh, absolutely.
Yeah, Google Workspace, so Docs, Sheets, Slides, Gmail, Drive just got a massive overhaul called Workspace Intelligence. That was also April 22nd on the Google Workspace blog.
Yeah. And the reason this completely changes the game is that it transforms Workspace from a standard productivity suite into an interconnected agentic substrate.
Okay, agentic substrate. That sounds very academic. What does that actually mean for the person trying to get their accounting done on a Friday afternoon?
Well, it means we are moving past the chat side panel. Right now, if you want AI help in a spreadsheet, you open a little chat box on the side and ask it a question.
Right, the little pop-out window.
Exactly. But with Workspace Intelligence, there is a unified semantic context layer underneath everything. The AI fundamentally understands the relationships between your files in real time. So if you get an email from a vendor, the AI already knows how that vendor's pricing matches up against the contract sitting in your Google Drive and how it impacts the budget in your Sheets file.
It's treating your entire digital office as one giant interconnected brain.
Yes.
And Google noted this allows for things like 9 times faster data entry in Sheets because the AI is anticipating the context. It's not just waiting for a command.
Exactly. But, Bridging all those different types of files, emails, spreadsheets, slide decks, audio recordings from meetings, that requires the AI to understand different formats equally well.
Right, and here's where it gets really interesting. This is the magic behind the newly announced Gemini Embedding 2 model, which hit general availability via the Gemini API on April 22nd.
On the Google AI for Developers site.
Yeah, and think of this as a universal translator for data.
A universal translator is the perfect way to look at it.
Yeah.
Technically speaking, it's a natively multimodal embedding model.
Okay, let's decode that for the listener.
Right.
What is an embedding, and why does multimodal matter so much here?
Well, an embedding is how an AI understands information.
Yeah.
It translates human data into a map of numbers, placing related concepts close to each other in a multidimensional mathematical space.
Okay.
In the past, if you had a training video, a PDF manual, and an audio recording of a lecture, you had to run the video and audio through transcription software to turn them into text.
Only then could the AI compare them to the PDF.
Exactly.
Which is an incredibly slow, complex data pipeline to build and maintain.
Oh, it's a massive friction point. But with Gemini Embedding 2, the AI directly maps text, image, video, audio, and PDF inputs into the exact same unified embedding space.
Oh, wow.
Yeah, it literally reads the pixels of the video, the wavelengths of the audio, and the text of the document in the same mathematical language. You no longer need to transcribe anything before an agent can analyze it.
So if an enterprise agent is trying to figure out how to fix a piece of machinery, it can watch a maintenance video, cross-reference it with a 500-page PDF manual, and listen to a voice memo from a mechanic instantly without any translation layers in between.
Exactly. It unlocks high-quality retrieval-augmented generation, which is how AI pulls specific, factual data to answer a question across completely diverse content types.
But let's take a step back and look at the physical reality of this.
Yeah.
If you are running millions of these concurrent agent workflows agents that are constantly analyzing video, reading PDFs, and doing multi-day test time compute reasoning, you can't run that on a standard corporate server.
Oh, no. If you tried, you would literally melt the data center. The sheer computational load is unimaginable.
Which is the perfect transition to the hardware explicitly built to prevent that from happening, the silicon layer. Google just announced their 8th generation tensor processing units on the Cloud blog on April 22nd.
Right.
But they did something highly unusual. They split the architecture into two completely different chips, the TPU 8i and the TPU 8i.
Yeah, this is a fascinating divergence.
I have to ask, why do this? I mean, every year, chip manufacturers stand on a stage and say, here is our new chip. It is 50% faster than last year's chip. Why go through the massive multi-billion-dollar engineering effort to design, fabricate, and support two entirely separate processors?
Because the physics of AI have fundamentally diverged. You can't optimize a single piece of silicon to do everything anymore.
What do you mean?
Well, think about what we discussed earlier. Training a massive new frontier model requires digesting petabytes of data all at once. That requires incredible throughput. It's like a massive freight train moving thousands of tons of cargo.
Okay, the freight train.
Right. That is what the TPU 8i is built for. The T stands for training. It delivers up to 121 ExaFlop teasers per superpod.
ExaFlop, yes. And for those keeping score, an ExaFlop is 1 quintillion mathematical operations per second.
Yeah.
It's a number with 18 zeros. It is raw, unadulterated power.
Exactly. But running autonomous agents in real time, what we call inference, is an entirely different physical challenge. You don't have a freight train anymore. You have millions of independent agents making rapid split-second decisions as they interact with users and databases. That requires ultra-low latency. It's like managing a fleet of high-speed sports cars dodging traffic.
Ah, so the freight train is terrible at dodging traffic, and the sports car can't pull 1,000 tons of cargo.
Precisely. And that's why the TPU 8i exists. The I stands for inference. To get that ultra-low latency, Google packed the 8i with massive amounts of on-chip memory, specifically SRAM.
Oh, I see.
By keeping the memory physically on the chip rather than fetching it from somewhere else, response times for agentic reasoning become near instantaneous. It delivers 80% better performance per dollar for inference tasks.
But, if we connect this to the bigger picture, you can have the fastest chips in the world, but if they can't talk to each other, they are useless.
Absolutely. Raw compute power means absolutely nothing if the network connecting the chips creates a bottleneck.
And that brings us to the Virgo network. Google unveiled this mega-scale data center fabric to underpin their AI supercomputers, also announced April 22nd. So what makes Virgo different from a standard high-speed network?
Well, it features a multiplanar design specifically for fault isolation, which goes back to our Decoupled DiLoCo discussion. But the sheer scale is what breaks records.
How big are we talking?
Virgo can link up to 134,000 of those TPU v8i chips in a single fabric.
Wow.
And it does so with up to 47 petabits per second of non-blocking bisectional bandwidth.
Wait, let me pause you there. 47 petabits is an absurd number, but what does non-blocking actually mean in reality?
Non-blocking means there are absolutely no data traffic jams. Think of a standard highway system. Even if cars are going fast, if everyone tries to merge at once, you get a bottleneck.
Right, traffic slows to a crawl.
Exactly.
Right.
But in a non-blocking network architecture, every single one of those 134,000 chips can talk to any other chip at maximum speed simultaneously without ever waiting in line.
Okay, so we have super intelligent agents capable of accessing private enterprise data, reasoning for days, powered by a non-blocking supercomputer. Sounds incredible.
It does.
Until you talk to a chief information security officer.
Oh, yeah.
Letting AI operate independently across a company's private data is a terrifying reality. It's an absolute nightmare.
It is the single biggest hurdle to enterprise adoption. How do you govern a workforce you can't actually see?
And that's the focus of the new Agentic Defense and Agent Governance rollout from Google Cloud Security, announced April 22nd on the Cloud and Security blogs.
Right.
How do we actually stop these agents from going rogue, downloading the CFO's emails, and sending them outside the company?
The core of this defense strategy is a new feature called Agent Identity. It assigns cryptographic IDs to every single agent. They also introduced an agent gateway and direct integrations with cloud security platforms like Wiz.
So think about this like giving a digital employee a highly restricted corporate badge.
Exactly.
Before this, an automation script was just a ghost in the machine. It executed a task, and it was very hard to track its exact permissions at scale. Now, an agent has a cryptographic identity tied to its actions.
It converts opaque automation into an accountable, auditable identity. It ensures that the agent can only enter the digital rooms or databases it is explicitly authorized to access.
So if a marketing agent tries to pull data from a highly secure HR database, its digital badge simply won't swipe on that door.
Nope.
The system logs the attempt and denies access, completely preventing rogue data leaks.
And it's not just about defense against your own agents either. Google is using autonomous SOC agents, security operations center agents, to hunt down external threats.
Oh, wow.
They disclosed that using these internal SOC agents has already reduced Google's own threat mitigation time by over 90%.
When the machines fight the hackers, the mitigation drops from hours to minutes. That's amazing.
It really is.
So the models are smart, the infrastructure is built, and the security frameworks are firmly in place. But the true test of this agentic era is market adoption. You and I might find the tech fascinating, but are companies actually buying this? Show me the money.
Well, the financial commitments from this week are unprecedented. Let's look at the partnership landscape. On April 24th, it was widely reported, like on CNBC, that Alphabet expanded its partnership with Anthropic, the makers of the Claude AI models.
Okay.
They committed $10 billion immediately, valuing Anthropic at $350 billion, with up to $30 billion more tied to performance milestones.
You know, you might be wondering why Google would give up to $40 billion to Anthropic. Claude is the direct primary competitor to Google's own Gemini models. Why fund your rival?
Because it is a brilliant, deeply strategic hedge. This deal cements Anthropic as Google's anchor customer for its custom silicon stack.
Oh, I see.
Yeah, it keeps Anthropic financially and operationally tied to Google Cloud infrastructure.
So whether the enterprise market ultimately chooses Gemini or Anthropic's Claude, the compute is running on Google's TPUs inside Google's data centers over Google's Virgo network. The house always wins.
Exactly. They win the infrastructure layer, regardless of who wins the model layer.
Yeah.
But the enterprise adoption of Gemini itself is also scaling massively.
Right.
Google launched a $750 million partner fund specifically to accelerate agentic AI adoption across industries.
And we are seeing the real-world scale of that right now. During the event, they showcased Merck, the pharmaceutical giant, executing a $1 billion AI deployment.
Huge numbers.
And Capcom, the video game publisher, is logging 30,000 hours of AI playtesting a month to find bugs before a game ships.
It proves definitively that Agentic AI has moved completely out of the experimental prototype phase and into core mission-critical production.
Which actually brings us back to the statistic you opened deep dive with.
Right. Sundar Pichai revealing that 75% of all new code at Google is now AI-generated and engineer-approved.
Yeah.
So what does this all mean? I have to ask you, is a tech company where human engineers are primarily just editors of machine-generated code a sign of peak utopian efficiency? Or are we looking at a looming technical debt disaster? It is easily the most polarizing, heavily debated metric of the entire week. On one hand, the utopian view is totally valid. It represents a staggering acceleration in productivity.
Sure.
Software features that used to take human developers weeks to draft can now be scaffolded in hours. By acting as editors, engineers can theoretically focus on high-level system architecture and creative problem-solving, rather than typing out boilerplate syntax.
But there has to be a catch.
The catch is risk management and deep comprehension. If an engineer is merely approving AI-generated code, do they truly understand the intricate underlying dependencies of that code?
That's a good point.
If a critical, complex bug emerges 6 months down the line in a system that a human didn't actually build, who knows how to fix it? Maintaining code you didn't write yourself is notoriously difficult.
So if the majority of a company's code base becomes a black box generated by an LLM, the accumulation of technical debt could be severe.
Exactly.
Yeah.
It demands a completely new paradigm of software testing, code review, and documentation.
Yeah.
It's a massive efficiency gain today, yes.
Yeah.
But it fundamentally alters the job of a software engineer tomorrow.
It really does. Which brings us to the end of an absolutely massive week of news. If we zoom out and look at everything that happened in Las Vegas between April 19th and the 25th, Google didn't just announce a few new chatbots.
No.
They shipped a vertically integrated operating system for the AI age, from the Virgo network and the highly specialized TPU 8i and 8i chips at the physical data center layer, all the way up through the secure Gemini Enterprise platform, right to the workspace intelligence layer and the email you check every morning.
Yeah.
It is an entire technological stack designed from the ground up to run thousands of digital employees.
It is a complete architectural shift in how human business operates. And as we transition fully into this reality, it raises an important question for you to consider.
What's that?
If companies are replacing massive chunks of their daily operations with autonomous agents, agents that process data, write software code, and communicate entirely in machine-to-machine protocols, what happens to institutional knowledge? When humans are no longer in the loop of daily execution, who actually knows how the company works?
It's a heavy thought, but an absolutely necessary one for the era we are now entering. Thanks for joining us as we unpacked this monumental week, and remember to keep diving deep.